Good morning, everybody. Jay Womack, founder and CEO of Infinity Workforce Solutions. Thank you so much for joining us today. Our webinar will begin in just a few minutes. I appreciate y'all sitting on hold. While we're here waiting for everybody to jump on, I want to give a special shout out to our existing clients that are here with us today. You are proving to your entire workforce that safety is your number one concern, it's your number one priority, and we appreciate that because we are very, very good at delivering training for safety, for orientation, for ongoing corrective action, and you obviously have taken the jump into the company right now and you're using it, you're saying that your people are valuable to you, and that's exactly what we want, that's what you want, that's what your people want to hear. So we do have all the answers. We know exactly what we're doing in web-based training. We've been doing this for 15 years, but I have a special offer today for our prospects that show up. We'd like to offer you a 30-day free trial using our system completely. See what it's all about. See if you like using something like this. You know, remote training has jumped to the forefront of the world. In the last 90 days, the world has shifted, it's changed. Remote training, we are the experts. We know more about remote training than virtually anybody in the entire, world, universe. So I want to offer the 30-day free trial. Time offer is limited. Yeah, we can't make this go on forever. I wish we could. I'm even going to throw in a CSR rep, a client service rep that can make this thing hum for you, get user activity up on the system, because that's the key, get your people to use the system. I don't care how many bells and whistles you've got, if they're not going to use it, it's not going to have an impact for your company. And at the end of the day, that's what we're all about. We want to see your top line and bottom line improve. We want to see your safety record improve. That's what we do, and we do that better than anybody out there. Thanks for sticking with me. In the meantime, it's what you came for. It's the webinar. So, Mark, if you're ready, I'm going to hand it over to you.
Good morning, good morning, good morning. Thank you, as always, Jay, for your commitment to our industry and supporting our professional drivers. And it's summertime, and we have a great webinar planned today on rubber meets the road. I'm sure everyone here has seen the remnants of tire failures on the side of the road. Some of you might have experienced some of those. And today I'm very excited to let you know we've got some experts, some engineers, some innovators in the field of tires, tire maintenance, and rapid air loss events from the Michelin company. So let's get going. My name is Mark Rhea. Most of y'all know me. I've been around the industry for 35 years, and it's a pleasure to represent Vertical Alliance and Infinity Workforce Solutions today. Just as a quick introduction, we've got joining us today from the state of California, Mr. Andy McCullough. Andy is the Field Operations Engineer for Michelin Engineering. He's a member of the Society of Automotive Engineers and is a certified tire industry instructor. Originally a Michigander, Andy is a graduate of Michigan State University. Also joining us from the bluegrass state of Kentucky, Brian Dingler. Brian is the Services and Solutions Sales Manager for Michelin North America. And also joining us from the Palmetto State of South Carolina, Mr. Charles Watley. Charles has got a long title there. I'm going to say he's the innovator for Michelin North America. He's got a lot of innovation technology things working. So we've got a lot of really great guests today. I want to start off with one quick question for the panel before we dive into the formal presentation. Tires represent a large, both direct cost to carriers and indirect cost to carriers. The indirect cost to carriers, of course, are downtime, but more important than that in our world here is rapid air loss can transfer into rapid vehicle control loss, which can turn into a rollover event or something really nasty that we're trying to prevent. So the impacts of proper tire maintenance, what to do in the event that you have a rapid air loss is what we're going to cover today. So just to kind of prepare you a little bit, we will put on your seatbelts. We will be simulating a rapid air loss event. And I would also ask you to grab a paper clip. Mr. Andrew McCullough will explain that as part of his presentation. So put on your seatbelt, grab a paper clip, and let's dive into this. You want to go to the next slide? So before we get there, I was going to ask the panel about those direct costs and those indirect costs. Can awareness training and information exchange impact those direct costs and indirect costs related to tires?
Thank you, Mark, and welcome everybody. Thanks for attending. The short answer to that question is yes, absolutely. There's certain things we can do, a number of different things that we can do that will help to mitigate both direct and indirect losses, and we'll get into those. Let's first try to understand what type of losses we're looking at and what the consequences of those losses are. So why do we care about loss occurrences? What's the importance of them? Well, there are multiple different direct and indirect costs associated with it. For instance, the average cost of an ERS call is about $700 plus per occurrence. And experience has shown us that each vehicle in a fleet will experience an average of about 1 to 1.5 breakdowns per year. Now, the NHTSA advises that these types of losses typically result in over 75,000 accidents per year. So there's a serious dollar value behind these rapid air losses and tire issues, and they can have both direct consequences to the fleet in the form of not just tire failures, replacing tires and damaged equipment, but indirect consequences as well, insofar as driver downtime, delays in shipments, and that sort of thing. So if we go to our next slide, air losses can be classified into two types. They can be a rapid air loss or they can be a gradual. But both of them are important. Both of them are of a concern to us. And there is a difference between the two. And if we go to the next slide, we'll show an example here. Here we have two tires that failed for two very different reasons. If you look at the tire on the left, that was a rapid air loss that resulted from an impact with a solid object. Now, this could be a pothole in the road. This could be a curb, a number of different things. But if you look at the rupture in the sidewall of that tire, you'll notice it forms a distinctive T pattern, a T shape. And that is almost always indicative of an impact failure. So we had that tire contact a sharp edge or object right at the center T of that rupture. And that impact caused the tire to rupture. It caused the casing plies to fail and a rapid air loss. Now, conversely, if you look at the tire on the right-hand side, that is what we call a zipper rupture. And that does result in a rapid air loss, but for a very different reason. The cause is a very different cause. This is typically caused by a low air pressure scenario. So we have a situation where a tire, for whatever reason, is underinflated. It may be from a slow leak. It may be a nail in the tire. The number of different things can cause it. But what happens is, as that tire rolls down the road, when it comes into contact with the road surface, what tends to happen is the tire flexes, the sidewall flexes. It's a certain amount of deflection that occurs in that sidewall as it contacts the road surface. When it leaves the road surface, it flexes back to its original position. And inside the tire, and you can see on that picture, there are a number of wires or cables which form what's called the casing plies. And these cables run radially hence the name radial tire, from one bead right around the tire radially to the other. And they actually flex as they contact the road surface. These are what support the load. It's actually not the rubber that supports the load, it's these cables. And now this is where our paper clip comes into play. These cables are designed to flex a certain amount, and that's perfectly okay. But what happens is when you have a tire that is underinflated or overloaded or both, the amount of deflection that occurs in those cables becomes very excessive. And the tire will actually flex in its sidewall beyond what it's designed to do. And that causes fatigue, sidewall fatigue. It causes these cables to sort of fatigue. So if we take that paper clip as an analogy to what's happening in the side of this tire, if we take that paper clip and we start bending it back and forth, the same thing happens with a coat hanger. I'm sure everybody's done this. You start bending it back and forth, and two things start to happen. One, you feel it starting to heat up, and that's because of the metal crystallization and the friction caused internally. And two, eventually, you'll notice what happens. It breaks. And the same thing happens to these cables in the casing ply. And it doesn't matter what type of tire it is, whether it's a Michelin or whatever brand. Any commercial tire that uses this manufacturing technology will experience the same sort of thing. So we get sidewall fatigue occurring, and these cables start to fatigue, and they start to fray, and they start to break. And over time, this leads to a situation with the condition we call the run flat condition. And it may very well result in a rapid air loss. As you can see, this tire resulted in a rapid air loss. It's called a zipper rupture because what literally happens is each cable breaks and snaps, and that puts additional strain and stress on the one next to it, which breaks again, and so on and so on. Very much like a zipper unzipping. That's why we call it a zipper rupture. So the importance of this is, the reason we touch on this is the number one cause of tire failures tends to be underinflation and or overloading. And this is why it's an important concern. It can lead to a gradual air loss, or it can lead to a rapid air loss. In either case, the net result is an air loss, a tire that has failed, and results in costs, direct and indirect, to the fleet. So let's go to our next slide, please. Hopefully everybody's following along here. So what factors can trigger a sudden air loss? What factors come into play and result in a tire failure? And there are a number of different factors, but the most important ones and the primary ones are underinflation or overloading, as we mentioned. And that's something that we can mitigate. That's something we can control in our risk management processes to help reduce. We also have road hazards and driving practices. Now, these are a little bit more difficult. You can get objects and hazards in the road, ranging from potholes to debris, all sorts of things. But we can mitigate those to a certain degree, depending on our driving practices and other external conditions. And of course, we also have heat and tire fatigue. And both of these are, to some degree, are related to our number one point there, the underinflation or overloading of the truck. Both will cause heat and tire fatigue. But we're also talking about heat and tire fatigue from other external sources. For instance, the temperature of the road surface, the conditions of the road that we're driving over, the amount of load that we're carrying, different things like that. So if we go to our next slide, please, we'll expand on that a little more. And at this point, it's worth noting that air loss occurrences actually increase, as I'm sure everybody's aware, during the summer months. In fact, our data, our experience shows that they increase by an average of 30 to 40% during the summer months. So that's a fairly significant increase. And the question becomes why? Why do they increase by so much? What causes that increase during the summer months versus cooler months in the winter? So if we go to the next slide, there's several factors that cause that are the result of this. Number one is, obviously in the summertime we have higher temperatures, increased road surface temperature and heat conditions. And this can be quite severe depending on the geographical area that we're operating in. We're operating down in South Texas, in the southern states. During the summer months, the road surface can actually become extremely hot. And again, heat and fatigue are both very detrimental to tires, all tires. So we get increased road surface temperatures that can start to affect the tire itself. And that can have a long-term effect on the tire's performance. The other thing that we get are different driving habits and tendencies. And this is something that maybe we don't necessarily think about. It doesn't come to mind immediately, but if you think about it, it's actually a fairly important contributing factor. During the summer months, we tend to be a little less cautious. During the winter months, we tend to drive a little more cautiously, whether it's snow or rain. We're always cognizant of the fact, unconsciously, that we have a slipperier road surface, that we have driving conditions that are maybe a little more perilous than in the summertime. So this tends to actually cause, you tend to naturally be a little more cautious in the wintertime and in cooler temperature driving. You tend to be more cautious. You tend to look out a little more carefully for road conditions and that type of thing. And that increased caution level actually helps avoid tire issues and other issues that are on the road. And finally, the last factor are loading and air pressure. Now, loading and air pressure really are always a concern and always a contributing factor to tire loss. But believe it or not, they tend to occur with a little more frequency during the summer months. And this is partly due to, the volume of freight that's moving around the country that's seasonal, and the number of trucks moving around and this sort of thing. I mean, that tends to hit peaks and valleys, highs and lows throughout the year. And the summer months typically tend to be their peak a period of time for this. So if we move to the next slide, please. So how can we mitigate these losses? What can we do to reduce them? This goes back to the question Mark asked at the beginning of this presentation. And obviously, we're never going to eliminate all losses. To some degree, losses are going to occur. It's just a natural part of life. It occurs, and simple fact of life. But we can mitigate them. We can practice risk management practices, which really will help reduce these losses. And the more we can reduce them, the less we experience as far as total direct and indirect costs with respect to those losses. Most tire failures are actually the result of underinflation. We discussed that, which causes the sidewall of the tire to flex more, generating heat and causing sidewall fatigue and failure. And that being the number one cause of tire failures, how can we change that? How can we help reduce those effects? And the answer is we actually can do that, and it's not that difficult. It requires a little bit of effort, but it's relatively simple. So next slide, please. We'll show you what can be done. Generally, a large portion of roadside incidents or tire failures are the result of just really two practices or two failures of practices. One is the failure to inspect the tires regularly, and this is key. And two is failing to maintain and replace those tires when necessary. Two very simple facts, But both of these facts have a tremendous effect on the amount and type of roadside failures that we do experience. Next slide, please. So the first point is inspecting the tires. Well, we all know that it's a federal requirement that the tires be inspected. As part of a pre-trip inspection, one of the things that needs to be done is inspecting the tires, checking the air pressure on those tires. And I always tell fleets, if you do nothing else with your tires, at least maintain correct air pressure. Usually with an inspection, both externally and particularly internally with some of our offerings that we have at Michelin, there are 6 critical factors that you want to look for. And we have them listed here in order of priority. Obviously, number 1 is low air pressure. A low air pressure condition will most likely cause tire failure over time. But we also do want to look for high pressure scenarios. Missing valve caps are important. Why are they important? Because the lack of a valve cap can actually cause dirt, water contamination to get into a valve stem and affect the core's ability to seal. So it can actually cause gradual air loss leaks, which lead back to our number 1 critical 6 factor, low air pressure. We also want to look for mismatched air pressure in duals and mismatched tread depths, and also irregular tire wear patterns, which can tell us about other factors with respect to the vehicle that are affecting tire wear. Now, there are several products and services that are out there that are available, a number of technologies that are available to help reduce this as well. But the most important fact is to do the inspection, to check the tires, to check the air pressures, and use an actual air pressure gauge, check the air pressures on the tires, and make corrections and/or repairs as necessary. If you find a tire that is a little low on air, and it's the result of a nail or a puncture or an object in the tire, have it repaired, have it fixed, tend to it as soon as possible, obviously. Next slide, please. Now, what do you do if you experience a sudden loss of air pressure? And this is where we get into the NTSB's, the National Highway Traffic Safety Association's statistic of 75,000 accidents a year. The sudden loss of air pressure, particularly in a steer tire, can cause an accident, and it can cause an accident particularly if you have a driver that's unprepared or weather conditions that increase the vulnerability or the instability of that vehicle on the road. But there are things that driver training that can be implemented to help reduce it when that happens. We know it's going to happen. We can help reduce the occurrences, but ultimately a loss of air pressure is going to happen. So it's important for drivers to be prepared for that and be familiar with what do we need to do in the event of a sudden air loss or a sudden air pressure loss in a tire. We have a video here, a short video, that actually does a very good job of explaining the behavior that's necessary to counteract that scenario, and also the reasoning behind that scenario. Why does a tire loss cause an accident? What tends to happen to the vehicle when air pressure loss occurs in a tire? So if you could run that video for us.
There's one situation that many drivers dread, one so buried in myth and rumor that even some of the professional drivers believe it cannot be handled. That situation, while rare, is the rapid loss of air in the tire. A blowout. First, let's take a look in slow motion at exactly what happens when a tire loses air quickly, because that's all a blowout really is, a tire that goes flat in a hurry. When it does, the front corner of the vehicle will drop, creating a side force. This side force depends on such factors as tire rolling resistance and vehicle dynamics. Although the vehicle will continue to roll along on the wheel and the deflated tire, the driver needs to compensate for this new side force. What do you do to maintain control? The answer is under your right foot. No, not the brake. In fact, panic braking is the worst possible thing you can do. Taking your foot off the accelerator is the second worst. The real solution is stepping on the accelerator. Getting power to the drive wheels means maintaining control. The accelerator is your best answer when there's a force pulling the rig to the side.
Oh, wait a minute, you say. I don't want to go faster. I want to stop right now. I'm going for the brake and hard. When you do that, you may lose control.
One of nature's basic laws says an object going in one direction, such as a rig on a highway, will keep moving in that direction unless it's acted on by a new side force in a different direction. In our diagram, the size of the arrow represents the magnitude and the direction of these forces. A rapid air loss creates a new side force. Unless the driver compensates for the side force, the rig will move in a new direction. By stepping on the accelerator, the driver starts to compensate. He completes the compensation by making a small steering correction. If you think about it, you deal with these external side forces all the time when you drive, especially in crosswinds or some high-crowned roads. All you do is step on the accelerator and correct with the steering wheel. There's no difference when a steer tire loses air. As the tire goes flat, a new side force begins acting on the rig. By stepping on the accelerator, making small steering corrections and driving your lane, you maintain control of your rig. Then, choose when and where to slow down and safely pull off to the side of the road.
Thank you. Now that's an excellent video. That really does a good job of explaining the type of behavior that we can implement to reduce the chances of an accident or a crash in the event of a rapid air loss. So we can boil that down to three basic steps. When a sudden air loss occurs when you're driving, number one is do not step on the brake. Instead, just ease into the throttle a bit. We say increase acceleration. That doesn't mean, put the accelerator to the floor, but we want to increase acceleration just enough to lessen the cross load or cross force that flat tire is causing on the vehicle. And then maintain steering correction. So you're going to gradually step on the accelerator and gradually correct for that cross force to keep the vehicle in a forward, straight line momentum position. And at that point, you then pull over as soon as it's safe to do so. But having regained control of the vehicle following the tire failure is key first. And that's why you want to slightly increase your acceleration and correct your steering. At that point, you can then pull over once it's safe to do so.
Andy,
next slide, please.
Yeah, Andy, hold on.
Yeah.
Just a quick comment.
Yes, Mark.
I'm looking at this and I'm thinking this would certainly be a fantastic opportunity to have a two-way discussion with your driving staff. What have you observed and what would you do in the event that you have a sudden air loss, either the passenger side or the driver's side? Just as an experiment, I asked my neighbor yesterday what would he do if he was driving his pickup and had a passenger side steering tire blowout, and his answer was I'd slam on the brakes and counter steer the other way. I said, okay, well that's wrong, but that's the normal answer. So it would just appear that an issue like this would certainly be beneficial to engage our driving staff on and have them actually exercise or simulate what they would do when something like this would happen.
Right, that's exactly right. I mean, it's human nature to want to instinctively step on the brake pedal and rapidly recorrect with your steering. And unfortunately, that's the worst thing you can do. That actually is what tends to ultimately lead to a complete loss of control and an accident. So it is, although it's your first instinct to do it, it's really the worst thing you can do. And the best way to overcome that instinct is to practice it, to practice getting used to applying the throttle slightly, correcting for your directional instability gradually. And you want to practice it enough so that when and if that ultimately does occur, it's become ingrained in you as a driver enough that you can instinctively then take those corrective actions without having to panic or suddenly think about it. Do you understand? Make sense?
Absolutely.
So definitely have a conversation with your driver over it, but practicing for those events definitely helps as well, and can help drivers be a lot more defensive and prepared when it comes to dealing with a rapid air loss situation. So by doing this, we ultimately help reduce the number of accidents on the road, which really ultimately reduces direct and indirect costs of a tire failure as well. And we do have, if we could go to the next slide. The important thing to remember is, many drivers will try to limp home on a flat, and that you don't want to do for a number of different reasons. Well, number one, it's a federal violation of CSA regulations to drive on a flat tire. But more importantly, you want to pull off the road as soon as it's safely possible. So that's really key. The other thing is, if you have a failure in a tire, let's say on your drive position, your trailer position, where you have the dual tires together, and you have a failure on one tire, that vehicle may very well still be able to roll down the road at a lower speed. But you don't want to do that, because ultimately with the failure of one tire in a dual position, you're putting additional load on that one surviving tire. And if you recall, we go back to our number one cause of ultimate tire failures, underinflation and overloading. So once you have a failure on a dual, say an outside dual fails, you're actually overloading the inner half of that dual tire application. So again, that's another reason that you don't want to try and continue driving on it. The important thing is to get off the road as soon as safely possible, and that's what we stress. Make sure it's as soon as it's safe to do so, not just for the driver, but for other drivers and around and others involved in the traffic flow that the vehicle is in. So to that end, there are a number of technologies out there that can actually help us monitor our tires, monitor our air pressure, can help with the inspection process when it comes to inspecting tires, looking for issues with them, and checking the air pressure as well. And we do have a couple of individuals with us today, as you mentioned, from Michelin, who are a little more involved with those technologies than I am myself, but they can expand on some of those technologies. Some of them are Michelin specific, some others are not. But the important thing is to do the inspection and maintain your air pressure. And remember, air pressure is critical based on the load and conditions you're driving in. So I get many people that ask me, many fleets that will ask me, well, what air pressure should I be running on my trucks? What's the ideal air pressure for me to run? And that's an excellent question. And the answer is, it depends. The real factor that determines the air pressure that you're going to run is the load that you're carrying, the maximum load weight. Now, obviously, 80,000 pounds is the max we can legally carry. But each tire and each application has a different air pressure that's recommended for the load that it's carried on. And if you look at air pressure charts for whatever brand of tire you're carrying, they will generally tell you what air pressure that tire needs to run. For instance, a drive tire carrying a fully loaded, typically if you're fully loaded most of the time, that drive tire may recommend an air pressure of, say, 105 PSI. Steer tires, different again. Trailer tires, also different. So fleets will generally set an air pressure standard for themselves. Typically, let's say 105 for the steers, 100 for the drives. they will maintain those air pressures as a fleet standard. When does it become a concern? Well, ultimately, an underinflated tire can be defined as a tire that has lost enough air pressure to the point where it's only at 80% of the air pressure typically run by the fleet. So if our drive tires are normally, if the fleet standard is 100 PSI for our drive tires, once we get down to 80 PSI, that's now considered a flat tire. And that's what we want to look for. That's how we determine, is the tire flat? Is it underinflated to the point where it's going to start causing an issue? So something for fleets to consider, what's going to be their standard air pressure for steer tires, for drive tires, for trailer tires. And those are generally, again, determined by the load or the weight that the trucks will be carrying, their maximum load, their maximum weight. And these can be found in the air pressure guidelines and tables that are published by all tire manufacturers. You can talk to your tire manufacturer rep. You can talk to your engineering rep. Internally within the fleet, it's important to come up with a standardized air pressure for your tires and stick to that and use it as a guideline for determining whether tires are underinflated or whether they're acceptably inflated. And I hope all this is making sense for everybody. It's a lot of it is just simple risk management maintenance, looking after your tires, checking the air pressures, being cognizant of road hazards and issues on the road that can lead to tire failures. It's really very simple, but it's surprising how often it tends to slip through our fingers. So typically, sorry, go ahead.
Well, I was just going to ask Brian. I know Brian's the services and solutions manager. If he had any input on, he or Charles, on some technology innovations or things that are in the works out there.
Yeah, no, Mark, I appreciate that. One of the things, Andrew, thank you for going through the details here of what causes these failures. And with what he was saying is it's the inspection. And most of the time, your inspection is either being done on the trust of, a servicing dealer. It could either be done just, on a trust factor, or it's done by pen and paper, or it may even be done on your yard. And again, it's only as good as the information that gets put in. And one of the things that Michelin has done over the last several years is really tried to become more of a solutions-based company. And part of that is trying to figure out where our fleets end up with, some of the biggest headaches, namely things like blowouts and roadside events. And so a lot of the things that we've noticed, especially with Michelin's on-call emergency roadside service, we started doing some research and realized that, the majority of our blowouts or tire failures were occurring within 50 to 75 miles of the yard. What that tells us is that tire was flat when it left. And so when you start going back and trying to follow up and say, okay, well, tell me about your maintenance program. Tell me about your air program. Tell me about how your inspections are done. And a lot of times they'll go back into a filing cabinet and they'll pull out a list of, grease-stained inspection papers and being done either with, a tire gauge that may have not been calibrated since, 1987, or we even have some of the old, the old tried and true baseball bats that check air pressures. And so what we've developed is a digital inspection platform. This offer is actually called Tire Care, and we utilize it through our Michelin dealers, or this is actually something that you guys can do on site at your own facilities. But basically what it does, it uses a digital tread depth gauge, a digital air pressure gauge, and a smart device, whether it's something, an iPhone or an iPad or Android, either one. And you can actually do a full inspection on a tractor and or trailer in less than 5 minutes. And it's a very accurate and detailed inspection. And if it's something that's remote, if you have a remote yard, this is something that your a servicing dealer can provide for you. And the reports are automatically generated. So if you end up inspecting, let's say you have 30 vehicles on the yard, this report will actually tag those critical 6 issues that Andrew was talking about and send that either to the servicing dealer and or to home base so they can be corrected. This information is invaluable because, one, it helps prevent downtime. It also helps prevent blowouts. And the information is actually stored I want to say indefinitely, but a very extended long period of time. So you actually have track of your inspections. In the event that you guys do happen to have an accident because of a blowout, you actually have some recourse to say, here's our inspection process. And it's a digital form that goes and actually shows the accuracy. So you actually are not going to get blamed for, malpractice is the wrong word, but get blamed for not inspecting or properly maintaining your vehicles. So this is a very popular offer that we've had for several years. But to tie into that, Michelin has taken another step forward to try to help mitigate events that happen on the road. If you're inspecting, like Charles was talking about, but as Andrew was talking about earlier, the majority of these events occur because the tire was improperly maintained before you left. Now, there's a lot of this can actually happen on the road. You pick up a nail, you end up having a valve cap valve stem or valve cap that starts to leak. And there's a lot of technology that Michelin has started to develop that will help alert the driver and the shop or home base, wherever you guys are located, before the blowout actually occurs. I was going to let Charles kind of speak to this because this is some of the newer technology that we've put out. And Charles is actually on our connected mobility team and gave us a little bit more information about how those work.
Yep. Can everybody hear me okay?
Yes, sir.
Okay, great. Yeah, and then cut me off if I talk too much. But as you said, nothing can beat a good inspection. And I love to use this simple example because there's some things, you are going to hit something on the road, and depending on which segment you're in, that can't be stopped. You're going to hit that object in the road, or you're going to be, in the case of your refuse, you're going to the dump, the landfill, and you're being exposed to rebarb and chunks of bricks and things. So with every segment, there's a different percentage of how often is there something that's unavoidable. That still runs in the 2 to 3% range. The rest of them can be avoided with proper tire care. And a real simple little example, if we go out there and measure your tires right now, take a measurement, and come back a year later and measure them again, the odds are there's something wrong. If we do that in 6 months, we just doubled our chance of catching an error. If we did that once a quarter, we just doubled it again. And as we found, the average time between inspections, the shorter you get that, the better your chances are that the tire's going to be fine. If we go out there and measure your tires right now, come in here, have a sip of coffee, go back out and measure them again, chances are they're going to be right where they were. And that's what we want to say. The more you inspect, the more you increase your chances of having that tire correctly inflated and catching any instances. So manual inspections are great, especially if they're done by a trained professional with good digital tools. But there reaches a point where, okay, we're doing them once a quarter, we're doing them once a month, we're doing them once a week, once a day, twice a day. That starts to get very expensive and maybe not even possible to have someone do it manually. So we have technology. We have a sensor, and there's 2 types of sensors. A sensor that can go inside the tire, which is the one we really like. We're a bunch of scientists and engineers, and when we stick that sensor inside the tire, we're actually capturing the temperature inside that tire. So we are allowed to adjust the temperature, the pressure reading, to a normalized reading with the temperature. What that allows me to do is, even though you get a little extra load on here, or your tires got hot because you've been driving all day, I can still look at that temperature, adjust it to the normalized pressure, and I can tell you if you're losing air over any period of time. So we're able to catch with the internal sensor. We're reading that thing every 2 minutes, and we are adjusting for the temperature, and we can detect a leak long before you'd ever see it, especially the slow leaks. And with the technology, we actually put a display in the cab, so you notify the driver. As soon as it starts to see, before it hits any, 10% down, 15% down, 20% down, we can tell the driver that you are losing air in this tire, and it allows them to take a preventative action. When they do get down, 10% off, then we can start sending notices off to text messages, emails, and such. The cream of the crop is sensor inside the tire, display in the cab, and we actually have a SIM card in your truck, which is constantly sending data to the cloud, and we're keeping up with all the data. You can back off that a little bit, and we have sensing stations which measure your tires every time we go by. So the sensors are in the tires. Every time you come home, every time you fill up at the gas pumps, we can put sensing stations in. And so now we're looking at measuring your tires, a couple times a day. So there's the technology, and technology is getting better and better. These are battery operated. They run 3 to 5 years, and so the technology is there, and we're seeing some very, very positive results from the fleets that are running these.
Well, that's exciting. That's something, the reality is when it's 110 degrees, it's pretty easy to talk yourself out of going out and manually checking tire pressures. So this temp sensor is certainly some a breakthrough technology. We're going to have to keep rolling here. I know we've got a lot of people that have some hard brakes. Can you go to the next slide, please? Okay, I would like to make sure that we are offering a free demonstration, 30-minute demonstration for our online platform that can assign these type of videos to your drivers to prepare them for the summer, to make sure they understand what is the reaction, the proper reaction in the event of a rapid air loss, as well as just familiarize themselves and make them aware of the reality of air loss problems and how to prevent those from experts that we've had on this panel from the Michelin company. So next slide, please. Here's my contact. Andy McCullough and Brian, we weren't able to get Charles in there. I'm sure that if they're interested in some of that information that you offered, they can. Actually, there's a next slide is the poll question, if I'm not mistaken. Next slide. Yeah. If you'd like information about workforce, the Infinity Workforce Solutions, just plop in a yes, and we will contact you on the free demo offer. If you'd like a representative from Michelin to contact you on some of the problems that you're experiencing in the field, some of the technology that's out there, or just some good old-fashioned advice on how to improve the bottom line for both direct and indirect costs, just click the yes, and a representative from Michelin will contact you accordingly. So again, the first question is if you want to participate in the free demo for Infinity Workforce, which of course we have 1,500 clients. We do over 350,000 assignments per month. And if you want to include some specifics on air loss problems and rapid air loss, hit the yes. We'll follow up with that. We do have a couple of questions. I'm out of time. Let me see if there's a question or two. Is there a recommended maintenance schedule for checking air pressure in tires? Charles, you answered that, which is if you do it once a year, you're going to have problems, and you exponentially improve that by the frequency that you actually do a manual or a remote or use some of the technology. Is that correct?
Absolutely. Very well stated.
I tell you, we are out of time. I don't want to impact anything else. We've got some great questions. One of the comments was, after regaining control on a steer tire blowout, I used the trailer trolley valve to decrease my speed. Doing this, I did not damage the wheel or rim and maintained control and stopped safely. What are your thoughts? Andy, did you want to?
You could certainly do that, but the real recommendation is to try and maintain your steering control and slow the vehicle down gradually once you regain control, in order to pull off the road at a safe location. So, and each circumstance is different. Tire failures occur for different reasons. They occur on different wheel positions, and what maybe works in one wheel position failure may not be as effective in another, but the steps that we laid out are universal. That will allow you to regain control of the vehicle regardless of which wheel position suffers an rapid air loss in the tire. So that's the important thing to keep in mind. Those are generally universal steps that, regardless of condition or application or wheel position that's failed, will be effective in regaining control of the vehicle and allowing you to pull over and stop.
Fantastic. I apologize for the questions that we weren't able to get to. I'm about 6 minutes beyond, so we're going to have to shut it off. Again, if you'd like some information or want to talk about some of your speed, how does speed impact your tire program, hit yes, or somebody from Michelin will contact you. If you'd like to take us up on Jay's offer for the free demonstration on Infinity Online Training to get this information out to the field for your drivers to avoid that rapid air loss that can transfer into a rapid vehicle loss of control, which we obviously got to stay away from. So I'm going to shut her down and wish everybody a happy journey. Thank you for all the people that participated. And we'll talk to you on Brake Check later this month. We've got the CVSA promotion on safety on brakes coming up at the end of the month. So thank you very much, and we'll talk to you next time. Thank you very much.